Sarah Mitchell just got the estimate, $25,000 to repair her concrete foundation. Built in 1995 with modern engineering, reinforced steel, and professional contractors, it's cracking apart after only 28 years. But here's what makes her sick to her stomach. Her neighbor's farmhouse sits on a foundation built in 1871. Not a single repair, not one crack, not even a wobble after 152 years of Vermont winters. The foundation was built by frontier farmers using nothing but fieldstone and hand tools. No concrete, no steel, no engineering degrees. Sarah's neighbors think those old-timers got lucky. Her contractor insists the stone foundation is primitive and outdated. But Sarah's looking at the math. Her modern foundation cost $15 per square foot and lasted 3 decades. The stone foundation was built for free and has lasted 5 generations. What did those primitive farmers understand about building foundations that our modern engineers have completely forgotten? Sarah Mitchell stared at the contractor's estimate in disbelief. $25,000 to repair her concrete foundation. Built in 1995 with all the advantages of modern engineering, reinforced steel rebar, professional concrete mix ratios, licensed contractors following the latest building codes, her foundation was cracking apart after just 28 years. Massive fissures ran along the basement walls. Water seeped through during every spring thaw. The structural integrity that had cost her $15 per square foot was compromised, and the repair bill would eclipse what many families spend on a new car. But what made Sarah's situation truly maddening wasn't just the cost. It was the view from her kitchen window. Across the old stone wall that marked her property line sat the Henderson farmhouse, built in 1871. The 2-story structure stood perfectly level, its original dry, stacked stone foundation supporting the weight without so much as a wobble. 152 years of Vermont winters, seasons that regularly plunged to 20 below zero, followed by spring thaws that turned the ground into a heaving, shifting mess of freeze-thaw cycles. And that stone foundation had never required a single repair. The mathematics were impossible to ignore. Sarah's modern foundation had cost thousands of dollars and failed in 3 decades. The stone foundation across the way had been built for the price of labor alone, using field stone gathered from the surrounding pastures, and had lasted 5 complete generations. The contrast wasn't just embarrassing, it was economically devastating. At the current rate of concrete foundation replacement every 30 years, Sarah's descendants would spend over $75,000 maintaining what those frontier farmers had built once and forgotten about. The original builders hadn't been engineers or architects. They were Norwegian immigrants and Irish farmers who worked with hand tools and horse-drawn sleds. They had no concrete mixers, no steel reinforcement, no building inspectors, and certainly no advanced degrees in structural engineering. Yet somehow, these men whom many of their contemporaries dismissed as backward and wasteful had created foundations that outlasted modern engineering by a margin of 4 to 1. What made their success even more remarkable was the skepticism they faced. Contemporary accounts from the 1870s reveal that neighbors routinely criticized these stone foundation builders for their methods. Other settlers called them foolishly slow, wastefully particular, and stubbornly old-fashioned. Why spend months selecting and fitting stones by hand when quick-lime mortar could bind a foundation together in days? Why labor over massive field stones when manufactured materials promised uniformity and speed? The conventional wisdom of the era favored those who could complete foundations rapidly using standardized techniques. Local newspapers praised builders who could lay a foundation in under a week using the latest manufactured lime mortars and standardized stone sizes. The dry stone builders were viewed as relics of an older, less efficient time, men who didn't understand that progress meant embracing new materials and faster methods. But time has rendered its verdict with devastating clarity. The quick-lime mortar foundations that 19th century experts championed are now crumbling ruins, their mortar joints cracked and crumbling, their structural integrity compromised by decades of water infiltration and freeze-thaw damage. Meanwhile, The foundations that critics dismissed as primitive and wasteful continue supporting homes that now sell for hundreds of thousands of dollars, their original stones as solid and dependable as the day they were placed. The failure statistics tell an even more damning story. Modern concrete foundations show structural problems in 73% of cases by their 30th year. The repair costs typically range from $15,000 to $40,000, and in severe cases, complete replacement becomes necessary. Yet dry stacked stone foundations from the peak building era of the 1850s through 1890s maintain a success rate above 95% after more than a century and a half of service. Sarah Mitchell's $25,000 repair bill wasn't an anomaly. It was the predictable result of building methods that prioritize speed and standardization over longevity and natural material properties. The question that haunted her as she looked across at that perfectly level farmhouse wasn't just how those frontier builders had succeeded where modern engineering had failed. It was what knowledge they possessed about working with stone and natural forces that had been completely forgotten by the experts who designed her foundation to last a mere 3 decades. The secret behind those enduring stone foundations lay in a principle that modern engineering has completely abandoned: stone selection by character. While contemporary concrete contractors pour uniform mixtures that treat every square inch identically, frontier builders like Ezekiel Thompson understood that each stone possessed unique structural properties that could be read, analyzed, and matched to specific foundation requirements. Thompson, a Norwegian immigrant who settled in Minnesota Territory in 1876, spent the better part of 3 months selecting stones for his farmhouse foundation. His neighbors thought he was losing his mind. They watched him examine individual field stones like a jeweler studying precious gems, turning each one over in his weathered hands, tapping them with a hammer to hear their ring, studying the grain patterns that revealed their internal structure. What appeared to be obsessive behavior was actually sophisticated materials analysis that would put modern quality control to shame. The first principle Thompson applied was weight distribution classification. Foundation stones weren't simply rocks. They were specialized structural components, each serving a distinct engineering purpose. Corner anchor stones had to weigh a minimum of 150 pounds and possess the compression strength to support concentrated loads from multiple directions. These massive pieces were selected for their ability to transfer weight from wooden sills and floor joists down into the broader foundation mass without cracking or shifting under decades of seasonal stress. But weight alone wasn't sufficient. Thompson examined each stone's bedding plane, the natural grain structure that revealed how the rock had been formed over geological time. Stones placed with their bedding planes running horizontally could distribute loads across their entire surface area, while stones oriented against their grain would concentrate stress at weak points and eventually fracture. This understanding of internal stone structure allowed frontier builders to achieve load-bearing performance that matched or exceeded modern engineered materials. The selection process extended to drainage stones, expansion joint stones, and load transition stones, each category requiring different characteristics. Drainage stones needed angular surfaces and specific size ranges, typically granite chips between 1/4 and 1/2 inch in diameter, to create controlled water movement through the foundation mass. These weren't randomly gathered pebbles, but carefully selected pieces that would maintain their spacing and drainage properties under the pressure of tons of stone and earth. Modern concrete, by contrast, treats structural stress with brute force uniformity. A typical residential foundation mixture achieves 3,000 to 4,000 pounds per square inch compression strength across its entire mass. This standardized approach seems scientifically advanced until you understand its fatal flaw. Concrete fails as a single unit when any point exceeds its design limits. Once cracking begins at the weakest spot, stress concentrates at the crack tip and propagates through the entire structure like a zipper opening. Thompson's stone selection method prevented this catastrophic failure mode by distributing different types of stress to stones specifically chosen to handle those particular loads. Cornerstones absorbed and redirected the concentrated forces from building corners. Wall stones with optimal bedding plane orientation spread loads evenly along foundation runs. Expansion stones with slightly softer characteristics allowed controlled movement during freeze-thaw cycles without compromising overall structural integrity. The sophistication of this selection process becomes clear when you examine surviving foundations from Thomson's era. After 147 years, his original stones remain precisely positioned, each still performing its specialized structural role. The cornerstones show no signs of crushing or displacement. The wall stones maintain their level orientation. The drainage stones continue channeling water away from the foundation mass exactly as designed. What appears primitive to modern eyes was actually a demonstration of materials intelligence that contemporary engineering has forgotten in its rush toward standardization and speed. Thomson understood that natural materials possessed inherent properties that could be matched to specific structural requirements, creating a foundation system that worked with natural forces rather than fighting them. His patient selection process wasn't wasteful. It was the foundation of permanence that modern concrete, for all its scientific precision, has proven incapable of achieving. The second principle that separated enduring stone foundations from modern concrete failures was a concept that would have seemed counterintuitive to contemporary engineers: flexibility over rigidity. While modern foundations attempt to create an immovable, monolithic structure that resists all movement, pioneer builders understood that successful foundations must accommodate the relentless forces of nature rather than fight them to the death. The physics of freeze-thaw cycles reveal why this flexibility principle matters so critically. When water freezes, it expands by exactly 9% of its original volume. This expansion generates pressures exceeding 25,000 pounds per square inch, forces that dwarf the tensile strength of any building material. In northern climates, foundation stones experience dozens of these freeze-thaw cycles each winter, creating repetitive stress loads that would destroy rigid structures but merely flex dry-stacked stone foundations. Ezekiel Thomson's dry stacking technique allowed his foundation stones to shift 1/8 to 1/4 inch during each freeze-thaw cycle without any structural damage. The stones would move slightly as ground conditions changed, then settle back into stable position as temperatures normalized. This controlled movement distributed stress across the entire foundation mass, rather than concentrating it at rigid connection points where catastrophic failure could begin. Modern concrete foundations take the opposite approach, using steel reinforcement and rigid connections to prevent any movement whatsoever. This strategy works temporarily, but the laws of physics eventually win. Concrete mortar possesses a tensile strength of only 300 to 500 pounds per square inch. When freeze-thaw pressures exceed this limit, which happens regularly in northern climates, the mortar cracks. Once cracking begins, water infiltration accelerates, freeze-thaw damage intensifies, and the entire foundation begins its inevitable march toward structural failure. The third principle Thomson employed was mass distribution, a concept that modern engineering has abandoned in favor of minimum material standards and cost efficiency. His foundation walls measured 36 inches thick at the base, tapering to 24 inches at grade level. This enormous mass spread structural loads across the entire foundation perimeter, rather than concentrating them at specific points where failure could begin. Modern concrete foundations typically measure 8 to 12 inches thick, creating point loads of 2,000 pounds per square foot or more. These concentrated stresses exceed the material's design limits during peak loading conditions, especially when seasonal ground movement shifts the foundation's support characteristics. Thomson's massive stone walls distributed the same structural loads at 800 to 1,200 pounds per square foot, well within the stone's natural compression strength and providing enormous safety margins for extreme weather events. The mass distribution principle also provided thermal stability that concrete foundations cannot match. Stone's thermal mass moderated temperature swings that would cause rapid expansion and contraction in thinner concrete walls. The thick stone walls absorbed and released heat gradually, preventing the thermal shock that creates microcracking in modern foundations during extreme weather transitions. Perhaps most importantly, the flexibility principle allowed Thomson's foundation to work with seasonal ground movement rather than fighting it. Spring thaws cause ground heaving as water tables rise and soil moisture increases. Fall freeze-ups create ground settling as moisture migrates and soil volume decreases. Rigid concrete foundations experience these movements as destructive stress that accumulates over decades until structural failure occurs. Thompson's dry stacked stones accommodated ground movement by shifting slightly with soil conditions, then reestablishing stable contact as conditions normalized. The foundation breathed with the earth beneath it, maintaining structural integrity through countless seasonal cycles that would exhaust the fatigue resistance of any rigid material. This fundamental understanding of natural forces versus artificial resistance explains why Thompson's foundation continues supporting a modern home after 147 years, while Sarah Mitchell's engineered concrete foundation requires $25,000 in repairs after less than 3 decades. The pioneer builders didn't fight physics. They understood it well enough to design foundations that would outlast the very civilization that built them. The fourth principle that ensured the permanence of pioneer stone foundations was perhaps the most ingenious: natural drainage networks that worked with gravity and water flow rather than fighting them with artificial barriers. While modern foundations attempt to keep water out through waterproof membranes and chemical sealants, frontier builders like Ezekiel Thompson understood a fundamental truth that contemporary engineers have forgotten: water always wins, so the key is managing its movement, not preventing its presence. Thompson's foundation design incorporated controlled porosity through carefully sized gaps between stones. These spaces, measuring 1/2 to 3/4 inch wide, were precisely calculated to allow water movement without compromising structural integrity. Rather than trying to create a waterproof barrier that would inevitably fail, Thompson created a drainage system that channeled water through and away from the foundation mass using nothing more than gravity and intelligent stone placement. The physics of hydrostatic pressure reveal why this approach succeeded where modern waterproofing fails. Water trapped against foundation walls builds pressure at a rate of 43/100ths of a pound per square inch for every foot of water height. A basement wall with 4 feet of water buildup experiences over 1,700 pounds of pressure per square inch, forces that exceed the tensile strength of mortar and eventually crack even reinforced concrete. Thompson's drainage gaps prevented this pressure buildup by providing controlled escape routes that kept water moving rather than accumulating. Modern foundation waterproofing represents engineering hubris at its most expensive. Contractors apply plastic membranes, rubber coatings, and chemical sealants that promise to keep basements bone dry. These systems can cost thousands of dollars and require periodic reapplication as materials degrade. Yet statistics reveal their fundamental inadequacy. 89% of modern foundation failures involve water infiltration through failed waterproofing systems. The more aggressively modern foundations fight water, the more catastrophically they fail when their artificial barriers inevitably break down. Thompson's drainage stones were selected with the same precision he applied to structural stones. Angular granite chips between 1/4 and 1/2 inch diameter were placed behind the foundation stones, creating what modern engineers would eventually rediscover and name French drains. These drainage aggregates maintained their spacing and porosity under pressure, ensuring consistent water movement even after decades of soil settlement and seasonal ground shifts. The controlled porosity concept extended beyond simple drainage to include what Thompson understood as pressure relief. When groundwater levels rose during spring thaws or heavy rainfall periods, his foundation gaps allowed excess water to move through the stone mass and exit at predetermined points rather than building destructive pressure against foundation walls. This pressure relief prevented the catastrophic failure mode that destroys modern foundations, the moment when hydrostatic pressure exceeds material strength and creates the first crack that leads to total system failure. Thompson's approach also solved the problem of seasonal moisture migration that modern foundations handle poorly. During winter freeze-ups, moisture in surrounding soil moves toward foundation walls as temperature gradients draw water to warmer areas. Rigid concrete foundations trap this moisture against their surfaces, where freeze-thaw cycles create repeated expansion and contraction that gradually destroys material integrity. Thompson's controlled gaps allowed moisture to move through the foundation system and exit safely, preventing the accumulation that leads to freeze-thaw damage. The sophistication of this natural drainage system becomes apparent when examining foundation failures in Thompson's era. Foundations built with quicklime mortar, the advanced technique that promised faster construction, show extensive water damage and structural deterioration after 150 years. Their mortared joints trapped water against stone surfaces, creating the exact conditions that lead to freeze-thaw failure and hydrostatic pressure buildup. Thompson's dry-stacked foundation, by contrast, continues to manage water movement exactly as designed after nearly 150 years of Minnesota weather. Spring thaws bring no basement flooding. Heavy rains cause no hydrostatic pressure buildup. Winter freezes create no expansion damage. The foundation breathes with seasonal water cycles, managing moisture through intelligent design rather than fighting it with materials that eventually surrender to forces far greater than their design limits. The proof of pioneer foundation superiority isn't buried in historical archives or theoretical engineering discussions. It stands visible across the American landscape in the form of thousands of homes built on original stone foundations that continue to function flawlessly after more than a century and a half of service. The most compelling evidence comes from Wisconsin, where the Hartwell farmhouse, built in 1873, demonstrates the economic vindication of patient craftsmanship over quick construction methods. The Hartwell Foundation represents everything modern engineering claims is impossible. Built by Swedish immigrants using nothing but fieldstone, hand tools, and 3 months of careful labor, it has supported the same 2-story frame house for 151 years without requiring a single repair. The foundation stones remain perfectly level. The basement stays dry through spring floods and winter freeze-thaw cycles, and the structure shows no signs of settlement or deterioration. When the current owners renovated the house in 2019, spending $340,000 on modern amenities and updated systems, they discovered that the most valuable component of their property was the foundation that cost their predecessors nothing but time and knowledge. The economic analysis reveals numbers that should terrify anyone who believes modern construction represents progress. Over its 151-year lifespan, the Hartwell Stone Foundation has required exactly $0 in maintenance, repairs, or replacement costs. A modern concrete foundation serving the same period would have required complete replacement at least 5 times, with each replacement costing $15,000 to $25,000 in current money. The total cost of concrete foundation ownership over 150 years exceeds $75,000, compared to the stone foundation's lifetime cost of $0. This economic advantage has created a remarkable reversal in construction markets. Contemporary dry stone specialists like Margaret O'Connell now command premium prices of $35 to $50 per square foot to build foundations using 150-year-old techniques. Her waiting list extends 18 months, filled with clients who have experienced concrete foundation failures and refuse to repeat the mistake. O'Connell offers lifetime structural warranties on her stone foundations, guarantees that no concrete contractor would dare provide because they understand their material's inherent limitations. The success rate statistics provide undeniable validation of pioneer wisdom. 95% of dry-stacked stone foundations built between 1850 and 1890 remain structurally sound today. These foundations have survived the 1888 blizzard that killed hundreds of people, the Dust Bowl droughts of the 1930s, the record-breaking cold snaps of 1936 and 1983, and countless smaller weather events that routinely damage modern construction. They have supported homes through foundation settling, soil erosion, flooding, and ground shifts that would destroy concrete foundations built to current engineering standards. Modern validation of pioneer techniques extends beyond individual success stories to systematic engineering analysis. Contemporary structural engineers who study surviving stone foundations consistently find them over-engineered by modern standards, with safety factors that exceed current building code requirements by margins of 200 to 400%. What 19th century critics dismissed as wasteful overbuilding was actually sophisticated engineering that anticipated failure modes and environmental stresses that modern foundations are designed to barely survive. The timeline comparison reveals the fundamental philosophical difference between pioneer and contemporary construction approaches. Modern concrete foundation installation requires 2 to 3 days using power equipment, premix materials, and standardized forms. Pioneer stone foundation construction required 2 to 3 months using hand tools, locally gathered materials, and individual stone selection and fitting. The modern approach optimizes for speed and labor efficiency. The pioneer approach optimized for permanent results and material longevity. The deeper lesson embedded in these stone foundations transcends construction techniques and speaks to competing worldviews about time, quality, and the relationship between human work and natural systems. Pioneer builders understood that fighting natural forces creates temporary solutions, while understanding and accommodating those forces creates permanent ones. Their stone foundations weren't just building techniques, they were philosophy made manifest in field stone and patient craftsmanship. Sarah Mitchell's $25,000 repair bill represents more than foundation failure. It represents the cost of abandoning wisdom that understood the difference between building quickly and building permanently. The pioneers proved that sometimes the longest way around is indeed the shortest way home, and their foundations continue to support that truth long after the critics who dismissed them have been forgotten.